Good afternoon, everybody, and welcome to another presentation from this year's Annual Corrosion Forum from ICOR 2022. We now have a presentation that's going to be given to us by Jonathan Francis, and the presentation title will be the use of magnetic probe coupler to augment existing equipment and technology. To give you a little bit of background on Jonathan Francis is a particularly minded individual who has 3 decades of experience in non-destructive testing with oil and gas industry and formal qualifications in 5 NDT methods: ET, radiography, eddy current, magnetic particle inspection, dye penetrant inspection. Jonathan holds a Bachelor of Science degree in NDT and in his 4th year as a part-time PhD researching the reliability of manual ultrasonic testing. Jonathan also has 7 years as an NDT inspector, downstream in oil refining, also in oil and gas platforms. He has a Bachelor of Science in non-destructive testing. He's got a NEBOSH General Certificate in Occupational Health and Safety, PNC Level 2 Radiography, Magnetic Particle Inspection, Dye Penetrant Inspection, and yes, he's very well versed in the subject. So over to yourself, Jonathan. Thank you very much.
Thank you. Good afternoon, everyone. So I'm Jonathan Francis, and today my talk is going to be on the use of a magnetic probe coupler to augment existing equipment and technology. So the outline of my talk today will be offshore oil and gas platforms, carbon steel pipelines, corrosion, manual ultrasonic non-destructive testing, reliability of manual ultrasonic testing, human factors, proposed solutions, and future research. Offshore oil and gas platforms. The North Sea contains over 100 oil and gas platforms. They are key in supplying energy to the UK and to the rest of the world. A typical offshore oil and gas platform can contain over 5,000 pipelines. This encompasses thousands of meters of fabricated steelwork. The pipework is of varying materials, and one of the most common materials used is carbon steel, often at least 50%. This is due to its cost effectiveness, ease of workability, and its strength. On a typical day, an inspector can inspect up to 1 to 2 pipelines, and these could vary in length from 5 meters to 30 meters. Carbon steel is a mixture of 2 main elements, carbon and iron. There are 3 main categories of carbon steel. You've got your low alloy carbon steel, medium alloy carbon steel, and your high alloy carbon steel. Typical carbon steel pipe used offshore is a medium alloy carbon steel, and these could be used for diesel fuel systems, cooling medium systems, or mud oil. Types of corrosion experienced on carbon steel pipes. So in this example, we've got an extreme case of external corrosion, and this is easily visible with the naked eye. Other corrosion we have is internal localized pitting corrosion on carbon steel pressure vessel in this example. So this is not easily detectable with the naked eye. It requires intrusive inspection or specialist inspection. Carbon steel is susceptible to corrosion. Corrosion is an expectation because corrosion is a naturally occurring process. In its simplest form, it is nature attacking the metal to try and return the metal back to its most stable form. This is an interesting quote from Chamberlain. It has been calculated that in the United Kingdom, 1 ton of steel is converted completely into rust every 90 seconds because corrosion is an expectation. We have probably all experienced corrosion, whether that has been in industry or even at home. One of the key causes of external corrosion is the environment. The offshore environment is an extremely harsh marine environment, and this accelerates external corrosion. Internal corrosion. Internal metal loss can be a result of corrosion or erosion. Pitting manifests itself randomly and is very difficult to predict and to detect. Pit sizes can range from 0.5 millimeter diameter, which would be classed as cone type pitting, to 20 mil diameter lake type pitting. So what are the causes of internal corrosion? It could be operational parameters, carbon dioxide and hydrogen sulfide, or breakdown on the internal coating of the pipework surface. Sweet and sour corrosion, carbon dioxide and carbonic acid get elevated levels of H2S. So H2S occurs during drilling and production offshore of oil and gas. Why manual ultrasonics for detecting internal corrosion on carbon steel pipelines? It is simple and yet highly sensitive to volumetric flow detection. It is cost effective whenever short distances or practical access to pieces under inspection are involved. No mechanized system exists which is as dexterous as the human hand. An operator can also cope with complex shapes and curved surfaces very easily. The equipment used is portable, low cost, and it provides instantaneous results. MUT of carbon steel, internal corrosion detection capability. So if you've got the internal pipework surface in a good uniform condition, then you'd expect to get excellent echo amplitude. If you've had erosion occurring in the pipework surface, then you expect to get a good echo amplitude. There'd just be a generalized thinning of the internal wall. With a lake type pitting, you would get a fair echo amplitude. And when you come onto your cone type pittings, it's very difficult to obtain a signal. You could be scanning along and completely miss the reduction in thickness due to the small size of the pit. And this you'd expect either no echo amplitude or a very low echo amplitude. The British Institute of Non-Destructive Testing Manual Ultrasonic Testing Guidelines, published in 2015, recommend a good measurement accuracy to be within plus or minus 0.2 millimeters for a thickness range between 0 and 25 mil. Any accuracy of plus or minus 1 millimeters or above is considered poor. It requires highly skilled and integrity-driven personnel. Current commercial equipment generally has no way of recording the scan. World large-scale studies have shown that the reliability of manual ultrasonic testing is substandard. So there's been the Program for Inspection for Steel Components, NORD test, which was carried out in Scandinavia, and the Program for the Assessment of Non-Destructive Testing in Industry, PANI 3, which was the report for the UK Health and Safety Executive. So the key findings from one of these studies: the reliability of manual ultrasonic testing inspection, as reported in the Program for Assessment of Non-Destructive Testing in Industry 3, for instance, established the probability of a given inspector finding a given fault at only 52% plus or minus 17% under typical test conditions. So typical test conditions on an offshore oil and gas platform: you could be working in a damp, cold, windy environment. You could be working off rope access. You could be working in confined spaces or restricted access. So these are the type of typical test conditions you would experience offshore. Human factors in manual ultrasonic testing examination. Human factors, they play a pivotal role in an MUT examination, and they all interlink. So if you take communication and procedure, for example, if you cannot communicate the procedure efficiently, then the procedure may not be carried out in the correct way. Training, this also interlinks with procedure. If you're not trained to apply the procedure in the correct way, then you could end up not following the procedure at all. Human factors models. The list of human factors is dense. Researchers have adopted human factors models to condense the factors into more manageable sections. There isn't one single ideal model. For my research, I've adopted Martin Waugh's category of human factors models for offshore oil and gas. So in October 2021, I carried out a survey, and there were 73 participants from varying industries such as oil and gas, petrochemical, nuclear, and aviation. And I wanted to find out the prevalence of manual ultrasonic testing in industry. And from the findings, it is still prevalent and widely used today. And one of the questions was, what would they feel would help improve the reliability of manual ultrasonic testing? And there was 3 clear answers. The task, detailed pre-job site assessment. So when the inspector gets to the job, gets to the site, they want everything to be ready so they can just carry out the inspection. Equipment. They want to be using modern and have varied equipment availability. When they're carrying out their research or training, they're usually using the latest equipment, but then when they get to site, they may be using older equipment. Of course, budgets don't always allow to use the latest and newest equipment. And the inspector recognizes that he or she needs additional training and that they're willing to carry out this training to help improve their NDT capability. So we need a simple, fresh approach to improve the reliability of manual ultrasonic testing in detection of internal corrosion-related flaws. A simple and effective piece of equipment will be developed. And this piece of equipment is very important that it augments existing ultrasonic equipment which is on the market today. Because, as I said previously, you don't always get the latest and greatest equipment due to budget constraints. So this ties into electronic waste. If we're not using the existing equipment we've got, then it ends up becoming electronic waste and obsolete. So only 12.5% of our e-waste is recycled. E-waste comprises 70% of our overall toxic waste. The majority of our e-waste ends up in landfill in poorer countries. So how are we going to improve the task, equipment, and help the inspector? The NIL study shows a drop in the plateau from 80% for a fully automated UT weld inspection procedure to 50% for the same procedure applied manually. A manual probe is manually moved across the test surface. How can we improve this? The magnetic probe coupler design. So the magnetic probe coupler, you insert the ultrasonic probe. It can be any ultrasonic probe into the coupler, and the coupler has magnets in the base. So then this couples to the carbon steel pipe so that when you're scanning overhead or horizontally or any position, you find a low reading, the probe will stay there. You can mark the reading on the pipe. The magnets ensure that you're holding the correct pressure when scanning. So then I move on to the experiment design stages. So I was kindly donated old weld samples from a local fabrication yard. So I set about cutting up the samples and preparing them ready for the experiment. From there, I'm looking to carry out a blind trial with and without the MPC. I'm hoping to gain feedback on the MPC from the participants so that I can make the necessary improvements to the design, and hopefully then it will get adopted in industry. So future work, 3D printing of the MPC, internal corrosion blind trial. I need to gain feedback from the participants on the use of the MPC to make the necessary improvements and adjustments, and production and adoption of the MPC in industry. So thank you to the sponsors of the event, Preserve, for this, and thank you to the Institute of Corrosion.
Thank you very much, Jonathan, for that excellent presentation. We'll now move on to a quick Q&A session. So first question will come from myself. So what comparable technology is available on the market?
So on the market, you've got automated ultrasonics, but this is a more expensive technique. And when there's short distances or small test pieces to carry out inspection on, then it makes more financial sense to use the manual ultrasonic testing. And most core crew NDT workers on the platform have the qualifications and they have access to a UT set to carry out ultrasonic testing as soon as it's requested from the client.
Okay, perfect. Next is, so I understand you're, based on your presentation, you're doing research in this area. Ultimately, what's the goal of your research?
So the goal of my research is to improve the reliability of manual ultrasonic testing, because as shown from the results from my survey, it is still widely used in industry, but the reliability of it is subpar. So I'm looking to make improvements to the reliability using that magnetic probe coupler to help the inspector when carrying out the examination.
Okay, perfect. And another question for myself. So as this is for energy transition conference, what other industries can you see this technology being used in?
I could see this being used across all the NDT industries, such as your aviation, nuclear, petrochemical. The aim of it is to be as simple and cost effective as possible, and to be able to be used with older equipment, which is still widely used today.
Okay, perfect. And just one more question for myself. If anyone would like to get in contact with you to find out some more information about your work, how can they reach you?
The best way to reach me is on the email on the last slide, jonathan.francis@northampton.ac.uk, and I'll gladly answer any questions or queries you have.
Okay, excellent. Are there any more questions from our panel today?
Yes, thank you, Jonathan, for a very interesting presentation. I do have one question for you. Now, I'm aware that with manual UT techniques, often there's a requirement for a fluid type couplant to be used to enhance signal propagation from the probe into the actual metal being investigated. How does that work for the magnetic coupler?
So there's no difference using the coupler to when you're just using your conventional probe, because you're still using the conventional probe. You've just got the coupler sleeve, which is covering the probe. So there's no difference when you're applying the coupler. You still apply the coupler. I was looking at perhaps introducing a. Oh, I lost track now. Sorry. Introducing a couplant insert into it, but then this would take away the simplicity of the device. And that's what I'm trying to do, is make it as simple and cost effective as possible so it can be adopted in industry.
Thank you very much.
Okay, are there any more questions? All right. If not, Institute of Corrosion would like to thank you very much for your participation today, Jonathan. That was a very comprehensive presentation, and we wish you every success with your project going forward. Thanks again.
Thank you, Olu. Thank you.
Okay, and to our guests listening, if you have any questions for us, please mail them to the Institute of Corrosion Gmail account, and we'll make sure that we can present them to Jonathan at a future date to allow him to answer them directly. Thank you all for your participation today, and we look forward to hearing from you in the near future. Thanks again.